So we're going to start a discussion by wrapping up the pros and cons of the Java ExecutorService framework. And we're going to look at this primarily in the context of the PrimeChecker app we've been using as a running case study throughout these lessons. Of course, the topics I'll be describing here generalize to other things as well. So if you recall, the early version, the first version of the PrimeChecker app used the executor interface and an implementation of that using a fixed size thread pool. This version that uses the ExecutorService interface fixes some of the problems with the earlier version. In particular, the earlier version used OneWay calls, so that required us to have an extra dependency within our Prime runnable objects on the main activity, which made some of the Android aspects a bit more complicated and convoluted and inefficient. So you couldn't do screen rotation of the phone to change its runtime orientation without having to shut things down or restart them. The nice part about the new approach is we've completely decoupled any dependency on main activity from Prime Callable, since now we have a two-way call. And so as a result, there's no reference to the main activity in a Prime Callable instance. And so this greatly simplifies runtime reconfiguration changes. Another thing we did is we added support for interrupts. So if you click the stop button on the GUI, that will trigger interrupts, which will tell the thread pool to shut down. It'll tell the thread that's sitting there waiting for futures to finish to shut down. And this will basically interrupt all the running tasks. So much cleaner, much more responsive, much easier to shut down gracefully. And that's a very useful thing in modern apps. People don't want to click the shutdown button and then have to wait for 2 minutes for everything to shut down. The way that this worked under the hood, of course, was we had the isPrime method, which of course is called in the background thread, check continuously to see whether or not it has been interrupted. And if it has been interrupted, then we go ahead and break out of the loop doing the prime number computation. And remember, computing whether a number is prime for a large number can take a while. So it's good to use the interrupts in order to be more responsive. As a consequence of all the things we just talked about, the runtime configuration changes are handled gracefully. And in fact, when you rotate the phone, you'll be able to have all the computations continue to run in the background. And as soon as the phone is finished destroying the old activity and creating the new one, the information that's in the new activity that corresponds to concurrent processing that took place while the phone was being rotated will just show right up on the GUI without missing a beat. So that's very cool. So it makes things more interactive. It makes things more performant. You don't have to start and restop. So it just makes everything much more seamless. But of course, as I always like to say, not everything is rainbows and unicorns. So there are still some limitations with the current approach. In particular, the way that the future processing model works, that thread that's running there processing futures, that uses the so-called synchronous future processing model, where the thread calling get, the background thread that basically waits for futures to complete, it calls it in whatever order the futures were created. And that may not be the same order that the futures are going to be completed. So creation and completion could be quite different because it all depends on how long operations take to run. And so it can make your app a bit less responsive if you have to wait for things in the order of invocation or the order of creation as opposed to the order of completion. And so what this means is that we're going to have to rethink this, and we'll fix this when we talk about the executor completion service and the completion service interface, which is another part of the executor framework. Because what it does, the completion service allows you to get the results as they complete, not in the order that they were invoked. So it just gives you extra responsiveness, which is nice. But that isn't what you get easily with the ExecutorService interface. Another problem here, which we had as a problem with the original implementation of Executor for the PrimeChecker app, is that isPrime is tightly coupled with Prime Callable. And so if you want to make any changes, you have to go in and extend Prime Callable or modify the code. And the particular approach we use here was intentionally designed to be inefficient. It's a brute force approach, but it would be hard to add a new algorithm without making changes to Prime Callable. And moreover, if we want to do something even more clever, like be able to cache results to avoid recomputing them if we've already looked them up once before, then that also is not something that's easily supported with this implementation. And again, we will come back and fix this with other examples we'll cover later in the course to make things more flexible and make them more configurable and more behaviorally parameterizable and so on. So that's just a quick overview of the pros and cons of the executor service. I think it's fair to say that the executor service is clearly an improvement over the Java executor interface because it gives you all these lifecycle operations. It gives you the ability to create tasks that are two-way tasks and do them in all kinds of interesting ways. You can spawn multiple tasks and run them together or wait for the first one to finish. So it's a lot more powerful than the Java executor. But there are still limitations, and those limitations will be addressed with further enhancements to the Java executor framework that we'll cover later, in particular the executor completion service and the scheduled executor service. But that'll come later in the course.